Okay, now I want to go over number 23. 23 tells us the polar coordinates, the radius is √2, and they give you a decimal. This is not a degree, it's a radian, just in decimal form. So remember, radians are in terms of pi. Like if you have 5 pi over 6, well, that's really 5 times 3.14. Remember, pi is 3.14 divided by 6, which is, if you put that in your calculator, 5 times 3.14 divided by 6. That is the decimal 2.62. And so we need to convert this decimal either to a radian in terms of pi, or we can change it to a decimal, or a degree. You can change it to a degree. So remember, if you want to get a radian, like if I was going to change 5 pi over 6 to a degree, I would just multiply it times 180 over pi, and these pi's would cancel out. So going from a radian to a degree, multiply it times this 180 over pi. So our radian is 2.36. Multiply it times 180 over pi, or 180 over 3.14. And so let's do that. 2.36 times 180 divided by 3.14. Alright, so my degree, so I'll just rewrite this. This is √2, my radius, and my degree is 135, close enough, 135 degrees. So that is what we need to graph. So my radius is √2 positive. So we'll start over here on the right side, and we'll go to 135. √2, the square root of 2 is like 1 point something. So we'll go to 135 would be here right in the middle. Okay, so remember, if the radius is 1, then what is the coordinate here? If the radius is 1, which on the unit circle radius is 1, the coordinate would be negative √2 over 2, positive √2 over 2. But the radius is not 1, it's √2. And so we're going to take √2 and multiply it times our xy coordinate. So I'm going to do √2 times the x part, which is negative √2 over 2. Alright, remember, if you take a root and multiply it, a √2 times √2 is just 2, so that's negative 2 over 2, which is negative 1. That's my x part. My y part, I'm doing √2 times √2 over 2. That's 2 over 2. That's 1. So my coordinate is negative 1, 1. Right, on the third part, they give us the rectangular coordinate, the xy coordinate, and they want us to give 2 sets of polar coordinates where theta is going to be a positive radian somewhere. It can equal 0, it can be greater than 0, and it's got to be less than 2 pi. So this needs to be a positive radian Alright, so the 35, they tell us the rectangular coordinate is negative 7, 0. So let's just plot that. Negative 1, 2, 3, 4, 5, 6, 7. Negative 7. There's the coordinate, and we need to come up with two sets of polar coordinates using a radian between 0 and 2 pi. Well, my radius can be positive 7 or negative 7. So let's say the radius was positive 7. Let's say we started over here on the right side. And I need a positive radian. So if my radius is 7 and I need a positive radian, so what would the radian be? If we go in the positive direction, we're going this way. It's pi. Okay, so that's one answer. Okay, the other answer would be if the radius is negative 7. The radian can equal 0. That's what this says up here, that theta is greater than or equal to 0. So this would be my other one. Okay, let's look at 37. Before I do 37, remember your special right triangles when your x and your y or your legs are the same length, like x, x, and x root 2. This is a 45, 45, 90 triangle. So anytime they give you a coordinate, it's a 45 degree angle, or it's a 45, 45, 90 triangle when the x and the y are the same. So like 37, they give you 1, 1. So when you plot that, that's a 45 degree angle. Your x and your y are the same thing. So 1, 1. And the radius would be 1 times root 2, or just root 2. Alright, so now that I know my radius, and I know where it is on the unit circle at 45 degrees, the radian is just pi over 4. And the radius is root 2. And so one polar coordinate is root 2 pi over 4. Okay, so let's come up with another polar coordinate that's different than this one. They want us to give two polar coordinates. So if you use the positive, you can use the positive root 2 again, so we would start on the right side. And what if we went in the negative direction? Well, it doesn't want me to go in the negative direction. It wants me to go in the positive. Theta needs to be between positive 2 pi and 0, so don't go in the negative direction. So let's give one for if radius is negative root 2. So we start on the left side. So if I start on the left side and we go in the positive theta direction, so we're starting over here and we go in the positive direction, where would that be in radians? So that would be, you go on 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So if I start at negative root 2, we'd be at 5 pi over 4. Alright, let's go over 39 now. 39. They give you the xy coordinate is negative 3, 4. Alright, this is a triple. Okay, so we need to figure out theta, the actual degree of theta from here to here. Alright, so we can use any of the trig inverse functions on your calculator. It's either sine inverse. If you do sine inverse, opposite over hypotenuse, sine inverse of 4/5, that's going to give you 53 degrees. That's this angle right here. I need to figure out where I'm at if I start in the positive direction and get here. So if theta is 53 degrees, to figure out what the degree is, if I start here and go here, you just do 180 minus 53. And I am at 127 degrees. So we need to change that to a radian. So 127 times pi over 180. Well, that's 127 times 3.14 over 180. So my radian is 127 times 3.14 divided by 180, 2.22. Okay, so we have our radius of 5, and we have our radian of 2.22. That's one polar coordinate. Let's come up with another one. So remember that theta has to be, it can be 0 or anywhere between 2 pi and 0. Well, 2 pi is 3.14 times 2 is 6.28. So if you come up with a decimal somewhere between 0 and 6.28, that'll work. You can use the radius of -5. Okay, so if my radius is -5, I need to end up here at the positive 127, so go in the positive direction. Where would that be? Well, you could do 6.28, which is that's 2 pi, minus 2.2. That'll give it to you. 6.28 minus 2.2. This would also work.